Very good morning, respected members. I warmly welcome all the participants to Day 1 Faculty Development Program on Fundamentals of Robot Programming. In today's Day 1 session, we are going to see about Introduction to Robotics and Robot Systems. It is my immense pleasure to guide you through the fascinating world of robotics where mechanical engineering, electronics, computer science, and artificial intelligence come together to create intelligent machines. Let us begin our journey into the world of robotics. So, this is our session introduction. So, why should every engineering faculty member understand robotics? Answer is relatively simple. Robotics has become one of the most important transformative technology of the 21st century. Today, robots are no longer limited to automobile factories. They are used in hospitals, agriculture, warehouses, construction, defense, education, and even our homes. A robot continuously performs three major important functions. First, it senses its surroundings. Second, it processes information and makes decisions. Finally, it performs physical actions. So this simply referred as sense, think, act cycle. So it forms the basic foundation of every robotic system. Let us now discuss the program objectives. At the end of today's session, we will be able to understand the fundamentals of robotics. You will learn the architecture of robotic system and identify their major components. You will understand the different classification of robots based on their application and configurations. Finally, you will appreciate how robotics is transforming industries around the world. Let us go through the session roadmap. Today's session has been carefully organized into 5 major important parts. We will begin with the foundation and history of robotics. Next, we will study the configuration of robotic system. Then we will classify the different types of robots. After that, we will discuss sensors, actuators, and control systems. Finally, we will explore real-world applications and the future trends in robotics. Let us now get into the problem introduction directly. So, what do you mean by robotics? How it creates a significant impact in various industries. Robotics is an interdisciplinary branch of engineering that focuses on designing, building, operating, and controlling the robots. A robot is a programmable machine capable of performing various a number of physical tasks with varying degrees of freedom. Unlike conventional machines, robots can sense their environment, process information, and respond intelligently. Essential characteristics of robots include programmability, sensing capability, autonomy, mechanical movement, and interaction with the humans or the surrounding environment. Let us go through the brief history of robotics. The journey of robotics began in 1950s, where the term robotics became widely recognized. In 1961, the world's first industrial robot, Unimate, was installed in a General Motors manufacturing plant. During 1970s and 1980s, industrial robots became common in manufacturing industries. The 1990s introduced mobile robots and artificial intelligence. Today, we are witnessing collaborative robots, autonomous vehicles, humanoid robots, and AI-powered intelligent robotic systems that are reshaping modern industries. Next comes the basic components of a robot. Every robotic system comprises of several essential components. The manipulator forms the mechanical arm. The end effector performs the actual work such as gripping, welding, or painting. Sensors collect information from both the robot and its surroundings. The controller acts as the brain of the robot by processing information and generating control commands. Actuators convert the electrical, hydraulic, or pneumatic energy into physical motion. Finally, the power source provides the energy needed for the robot to operate. Let us now understand the different classification of robots by application. Robots are classified according to where they are used. Industrial robots perform welding, assembly, and material handling. Medical robots assist various surgeries and rehabilitation specialists. Agricultural robots support harvesting, spraying, and crop monitoring. Defense robots carry out surveillance and bomb diffuser. Service robots assist in hotels, hospitals, and homes. Exploration robots are deployed in space missions and underwater environments. Each application requires specialized robotics design and control systems. Let us now go through the robot configuration. Generally, robots are classified based on the mechanical configuration. Say Cartesian robots move along straight X, Y, and Z axis. Cylindrical robots combine rotary and linear movements. Spherical robots operate within a spherical workspace. SCARA robots are widely used for high-speed assembly operations. Articulated robots resemble the human arm and are the more versatile industrial robots. Each configuration requires unique advantages depending on the intended applications. So the next thing we are going to see about the most important the terminology in robotics, say degrees of freedom. So degrees of freedom describes the number of independent movements a robot can perform. So 3 degrees of freedom determine the position. Another 3 degrees determines the orientation. Many industrial robots have 6 degrees of freedom, enabling them to reach almost any position and orientation within their workspace. Some advanced robots possess 7 or more degrees of freedom, providing greater flexibility and obstacle avoidance. Next thing we shall go through forward and inverse kinematics. So what is the discrimination between forward and inverse kinematics in robotics? Kinematics studies about the motion of a robot without considering the impact of forces involved in it. Forward kinematics determine the end effector position from known joint angles. Inverse kinematics calculates the joint angles required to reach a desired position. So these calculations are very important in robot programming and are extensively tested using simulation software before implementation on physical robots. Let us understand how sensors plays a major part in robotics. Sensors are the main integral part of a robot. Internal sensors measure position, speed, orientation, and applied forces. External sensors include cameras, ultrasonic sensors, lidar, proximity sensors, and tactile sensors. Together, these sensors allow robots to understand both their internal condition and the surrounding environment, enabling intelligent decision making. Next, let us see the significant importance of actuators and drive systems in robotics. Actuators generate robot movement. So for that, electric motors are commonly used because of their precision and ease of control. Hydraulic actuators produce very high force for heavy industrial applications. Pneumatic actuators provide fast and economical motion for lighter tasks. Selection of a drive system depends on the speed, accuracy, load capacity, and operating conditions. So now we shall go through the importance of controllers and robot programming. Controllers mainly serves as the robot's brain. It continuously receives the sensor information from the external environment. Accordingly, it tries to execute the programmed instructions and control the actuators to move various mechanical parts of the robot. Robot programming can be performed using teach vendors, offline simulation software, programming languages such as Rapid or KRL, and increasingly through AI assisted programming techniques. Modern robots are becoming more easier to program while offering greater flexibility and intelligence. Next concept we are going to discuss about the closed loop feedback control system. Most modern robots operate using loop feedback control. Controller compares the desired position with the actual position measured by the sensors. If any error occurs, the corrective commands are immediately generated. This continuous feedback process ensures high accuracy, stability, and precision during robot operation. The importance of robot simulation and digital twin. Let us see some of the basic information regarding to that. Before deploying a robot in a factory, engineers create a virtual model. In developing the virtual model, so we have to see the basic geometry of a robot, its physical motion, collision detection, and control algorithms. So these are the main information that are being tested in simulation software. Once verified, the program is transferred directly to the physical robot. This digital twin approach minimizes the development time, reduces cost, improves safety, and enhances overall system performance. Now we shall move on to the main important thing according to the session roadmap. So real-time application of robotics. Today, robotics impacts nearly every industrial sector. In the view of manufacturing, robots are being utilized for performing welding, assembly, painting, and inspection. In the case of healthcare, they employ robots for performing surgery and patient rehabilitation. Agriculture benefits from autonomous harvesting and crop monitoring. Defense heavily relies on robots for hazardous operations. Service industries use robots for cleaning, hospitality, and delivery. Space agencies employ robots for planetary exploration and satellite maintenance. So the possibility continue to expand every year, the same similar way. So let us now discuss the future trends in robotics. The future of robotics is extremely exciting. Artificial intelligence is making robots more intelligent and autonomous. Collaborative robots are enabling human as well as robots to work safely together. Swarm robotics demonstrate how multiple robots can cooperate to complete complex tasks. Humanoid robots are becoming increasingly capable of interacting naturally with people. The future belongs to intelligent, connected, and human-centered robotic system. Let us now summarize today's learning. The robots integrate sensing, control, computation, and mechanical motion into one intelligent system. Every robot comprises of manipulators, actuators, sensors, controllers, and power systems. Robot configuration and degrees of freedom determine their capabilities. Sensors enable robots to perceive their work environment. Artificial intelligence is driving the next generation of robotics across various industries. I sincerely encourage all the faculty members to continue exploring this exciting field and inspire students to participate in robotics research and innovation. With this strong message, I thank all the members for your active participation and attention throughout today's session. I hope this introduction has provided a strong foundation for understanding the robotic systems. In our upcoming sessions, we will explore the following topics like robot programming, motion planning, simulation, and practical applications in greater detail. Thank you once again, and have a wonderful learning experience.